We're going to go ahead and take a look at number 43 from section 10.4, dealing with area and circumference. So I'm going to go ahead and quickly jot down the figure that we're going to be working with in the upper right hand corner. I would also suggest that you have your textbooks pulled out to page 648 in order to follow along, because the problem actually is quite involved. And then I'm just going to go ahead and color the roof in orange. This is an area that's actually shingled, so we're not going to be concerned about this particular piece. But basically, let's begin. So number 43 says you are planning to paint the house whose dimensions are shown in the figure. So what we do know in this particular case is that this triangular piece has a height of 10 feet. The front portion of the house has a height of 20 feet and a length of 40 feet. And then the side of the house has a base length of 50 feet. Okay, we want to know how many square feet we will need to paint. There are going to be 4 windows, each that are going to be 8 feet by 5 feet. We also have 2 windows that have dimensions of 30 feet by 2 feet, and we also have some doors that have dimensions of 80 inches and 36 inches. So before I actually do that, I'm going to do a unit conversion, because notice that everything is in feet, and they're asking you how many square feet you are going to have to paint. So it doesn't make sense to leave the information that you have about the door's dimensions in inches. So we know that one of the dimensions is going to be 3 feet. So in order to convert this, I know that they're in 30, whoops. Let me start over. So we know that we have 36 inches as one of our dimensions. So we know that this is going to be, there are 12 inches in 1 foot. So what I'm doing is I'm setting up almost a multiplication problem that involves rationals. And by doing this, this allows me to cancel out the inches, and this leaves me with 36 feet over 12, or 3 feet. So we know that the door has a width of 3 feet. And then we also have information that says that the height of the door is 8 inches. So we can go ahead and do that unit conversion again. Can cancel out those inches, because technically what you're doing is you've reduced the unit out, because one of the units exists in the numerator and the other unit exists in the denominator. So then this results in 80 feet over 12, which simplifies to 20 over 3 feet. I know that that's not ideal to work with a fraction, but it is actually better in the long run, because the fraction actually is it encases the entire value. We're not going to run the risk of creating a rounding error, because we will not be rounding or using a decimal approximation. So now we need to know the area of the house that we're going to be painting. Well, note that one portion we do have a triangle. Another portion we do have the front of the house. And I'll go ahead and note what these dimensions are. So we have a height of 10 and a base of 40. Again, use the context clues of the figure in the book. We also have 20 by 40. And then we have the side of the house, which has a dimension of 50 by 20. But of course, we're not just going to paint the sides that we see in the figure. I mean, this is one of the drawbacks to working with a 3-dimensional figure on a 2-dimensional space. So there's actually double these sides. There's a front and a back. There are two sides, and then there obviously, since we have a triangle on the front, there's going to be a triangular shape on the front and the back as well. So in order to find this area, we need to sum this up. Okay, so the area for this one is going to be 2 times the area of the triangle, so that will be 1/2 times the height times the base. And then we will do 2 times the area of the front rectangle, so 2 times the base times the height, plus 2 times the side triangle, so 2 times 20 times 50. Okay, this is going to cover the entire area of the house that we're going to be painting. So if we were to perform this multiplication, I would go ahead and, for the sake of saving space on the sheet of paper, I'm not going to work out all of these calculations, but I do have a pretty good setup for you. Go ahead and complete these calculations. Pause the video and work on this. Make sure that you understand where all of the information is coming from and why it has been pieced together the way it has been. When you do this calculation, you're going to get 400 square feet, or sorry, not 400, 4,000, it's much bigger, 4,000 feet squared. Okay, but this is assuming that you live in a house without any windows or doors. So now what we need to do is we need to find the area of these windows and doors. So what I'm going to do in blue is going to be the area of your windows and doors. So we have 2 windows that are rectangular in shape that have the dimensions 30 by 2 feet. We also have 2 doors that have the dimensions of 30 by 20 over 3 feet. And if you were to look at the decimal approximation, or if you were to look at the proper fraction, that's 6 2/3 feet. Then we also have 4 windows that have a rectangular dimension of 8 by 5. So again, if you were to do this calculation, this is actually going to total out the area of the house that will not receive paint. Obviously, we're choosing to not paint the doors the same color as the house. I don't know, I would walk around your neighborhood and kind of note, people usually have a statement door or a door that is slightly different than the rest of the house, so that that piece of it stands out and the rest of the house doesn't look so monochromatic, if you kind of think of it from an artistic standpoint. And we obviously don't apply paint directly to the windows because we want to be able to look out of our windows. So if you were to take care of this calculation, do the multiplication of 2 times 30 times 2 plus 2 times 30 times 20/3 plus 4 times 8 times 5, this amasses to 320 square feet. So now, in order to find the area that we paint, we're going to take the total area of the house minus the area that we will not paint. So that means that we are going to paint 3,680 square feet on this home. Okay? So that answers part A. Part B says the paint that you have chosen is available in gallon cans only. Each can covers 500 square feet. If you want to use 2 coats of paint, how many cans will you need for the project? So note that you are going to do 2 coats on this house. So let me go ahead and kind of do a dividing line here. So we're going to do our work underneath the orange line. So 2 coats really means that I'm going to paint the house twice. So in other words, I'm going to do 2 times that 3,680 feet squared, or square feet. Okay, because I'm going to paint the house once and go, yes, good job, I'm awesome, I'm done, and I'm going to do it all over again. So instead of really painting 3,680 square feet, I'm actually going to be painting 7,360 square feet. And note, I did write the dimensions a little bit different. You could have also, again, written it as feet squared. Okay, it's saying the same thing, you just are using a different notation. But either way is fine. So now that I know this, I know that each gallon can of paint is going to cover 500 square feet. So in order to find out how many cans I need, I need to go ahead and do the following. So number of cans needed is going to be, well, I'm going to take that 7,360 square feet and I'm going to divide it by 500. In doing so, I'm basically breaking that entire surface area that I'm working with into chunks. So if I can find out how many chunks of 500 square feet I can get from the 7,360, that clues me in how many cans of paint I'm going to need. Well, this comes out to 14 72/100 cans. So we're going to have to do a decimal approximation here because, well, you can't walk into a store and say, I would like to buy 14 72/100 cans of paint. They're going to look at you rather odd. You know, you either buy a whole can or you don't buy anything at all, especially in this problem since they're saying that the color that you are looking for only comes in the gallon option. So I'm obviously going to want to round up. Okay, if I only get 14 cans, then that means that there's a portion of the house that's only going to receive a single coat of paint on it. And that runs the risk of making it look slightly odd, especially if you're painting over a different color. So I need 15 cans of paint. That answers part B. So coming over here to this rectangular area that I have sectioned off in orange, let's look at part C. If the paint you have chosen sells for $26.95 per gallon, what will it cost to paint the house? So ironically, at this point, we started off with a very calculation-intensive problem, and now we're ending on what I would consider a bit of a light note. So to find total cost, we're going to take our 15 cans and multiply it by the price per can. So this is going to amass to about $404.25 to paint this entire house. Okay, so there you have it. Your final answer for part A is circled in the bright blue. Your answer to part B is circled in the aqua color, and your answer to part C is in the dark green. I hope that this was helpful. If you have any additional questions, please let me know.